Hello friends, welcome to Math Solution Academy. Now we talk about algebra problem in NBHM 2018. The problem is which of the followings are prime ideal in the ring C continuous function in the interval 0 1. The three options are f belongs to C of 0 1 such that f of x equal to 0 for all x greater than equal to 1 third less than equal to 2 third. And second option is j equal to f belongs to continuous function on 0 1 such that f of 1 by 3 equal to 0 and f of 2 by 3 equal to 0. And the third option f belongs to continuous function on the closed interval 0 1 such that f of 1 third equal to 0. Now we check the first option, that is this is prime ideal or not. If now first we define what is prime ideal. Let R be a ring. An ideal P not equal to R is said to be an prime ideal if A B belongs to R such that A B belongs to P. This implies either A belongs to P or B belongs to P, and this ideal in that case P is prime. So now we check the three options which is prime or not. Now we check the first options. The first option becomes j equal to continuous function on closed interval 0 1 such that f of x equal to 0 on an interval x less than 2 third greater than equal to 1 third. Now friends, we take two real valued functions, continuous function of course, on closed interval 0 1. Now we draw, and this is on closed interval 0 1, and this is a half point, and say this is 1 third point, and say this is 2 third point, and take it, suppose this is 1 third, this is 2 third, and this is half point. And now if we take two functions such that if, now first of all of you know that this is not an integral domain, because in that case there are divisor of 0 in continuous function on closed interval 0 1. If I take two functions such that fx equal to say suppose fx equal to 0, x greater than equal to 0 less than half, say here we take, actually we prove that f function is 0 in that interval and g function is 0 in that intervals, and so we take such a functions, and x minus 1 half, and this is take half less than equal to 1, and this is clearly an continuous function. And take another function gx, this is equal to x minus half such that x greater than equal to 0 less than half, and 0, take it 0 if x greater than equal to half less than equal to 2 third, and in other case we take 2 third if x greater than 2 third less than equal to 1. This is also an continuous function. This is both continuous functions. The first function here, f is, here in that case f is 0, actually f 0 in the total interval, but the question is to find just in that interval. So here f is 0 and here g is 0. So we take two functions such as we defined here. Now you see that since f is 0, since f is 0 here and g is 0 here, here g is 0. So fg, so fga x is 0 for all x less than equal to 2/3 greater than equal to 1/3. Why? Because f g x, this is equal to f of x into g of x. So this is 0 in that interval. Since we take two functions, f of x 0 in that interval and g is 0 in that case. So f of x, g of x 0 in the total interval. But you see that f is not identically 0. Sorry, f is not identically 0 on x less than equal to 2/3 greater than equal to 1/3. Similarly, g is not identically 0 on x less than equal to 2/3 greater than equal to 1/3. Why? Because from the definition, if x greater than half, then this is x 2/3 equal to x 2/3 is x 2/3. So here x 2/3 is not equal to 0. Similarly, here x 1/3, here x 1/3 is not equal to 0. But fg is identically 0 on 2/3 less than equal to 1/3. So therefore fg belongs to j, but f not belongs to j, j, and g not belongs to j. So hence j is not prime. So the first option, that is wrong. The second option is f of 1/3 equal to f of 2/3 equal to 0, and this is also false, because you see that here f of 1/3 is not equal to 0, but here f of 2/3 equal to 0, because this is 0, f of 2/3 equal to 0, and here f of 1/3 equal to 0, but not identically 0, f of 1/3, and g of 1/3 not identically 0, but f of 1/3 equal to 0 and f of 2/3 not equal to 0, but g of 1/3 not equal to 0, but g of 2/3 this is equal to 0. So f g of 1/3, that is f of 1/3, g of 1/3, this is 0, and f g of 2/3 is similarly 0. But so f g belongs to j, but f not belongs to j, g not belongs to j. So therefore j is not prime, since this is hold. So the second option is also false. Now we check the third option. The third option says that f of 1/3 equal to 0. First of all, this is a real valued function. So f of 1/3 gives two real number. So if we say that f of 1/3 equal to say 1a, and f of g of 1/3, say it b, since f and g are both real valued functions, this is r to r. So this f of 1/3, and so f gives a real number at one point and g gives a real number at one point. And by the given condition, if f g 1/3 equal to 0, and this implies f of 1/3 g of 1/3 this is 0. So since this is real number, two real number, this is 0, and since real number is a field, from a field, so this does not contain any divisor of 0. So this implies either a equal to 0 or b equal to 0. So fg belongs to J, this implies either F belongs to J or G belongs to J, and that's why hence J is prime. So the third option is true, and the first and second option are false. Thank you.